Hi, I'm Peter and I'm the main developer of ViKiD.net. ViKiD is a web platform that helps you acquire modern reactive programming skills. In this video we will explain why we worked 12 years to create ViKiD and why we believe children should also learn this new style of programming. Allow me to briefly introduce myself. I started programming on the Commodore 64 in 1985. Then I made several commercial video games on the Commodore Amiga, followed by the development of custom 3D animation software, video games on Xbox and interactive procedural art on the PlayStation 3, and then I switched to teaching applied mathematics and physics at universities with video game programs. Now I'm a senior software developer at NVIDIA working on the Omniverse platform. So, first a big disclaimer, ViKiD was created before I joined NVIDIA, and all my opinions are mine and not necessarily those of my employer. So, why did we create ViKiD? Well, 12 years ago, my 5-year-old son wanted to make video games. At first I thought it was impossible at that age, but we found MIT Scratch and had great fun with it. Because it is such a fantastic experience, I joined Coder Dojo, where I'm a volunteer that helps young children build video games, mostly with Scratch. But something feels wrong with Scratch. As the games become more complicated, for example when building a Space Invaders game, it becomes very hard to figure out what is wrong in the program code. In this video, I will explain why I believe this is the case and why ViKiD could be a step in the right direction to solve these problems. First of all, Scratch is an imperative old-school programming language. Imperative means it is all about doing stuff. Moving a sprite, stopping a sound, changing the world in general. To store information, imperative programming uses variables that are read and written. To demonstrate the problems with these variables, let's use Microsoft Word to convert inches to centimeters. We make a table with 2 columns and insert the formula in the second column. We see that the centimeter cell is updated correctly. Let's now change the inches cell. Notice that the centimeter cell didn't update. To fix this, we need to update the cell explicitly. So in order to synchronize both cells, an extra action is imperative. Let's now do the same with spreadsheet software. As we all know, in spreadsheets, cells update automatically. And indeed, if we change the inches cell to 42, the centimeter cell automatically updates. No extra action is needed. This is called reactive programming. The centimeter cell reacts on changes to the inches cell and is automatically updated. ViKiD also works like a spreadsheet. Here's an example of converting the inches to centimeters by applying the same formula. If we change the inches value, we see that the centimeters value automatically updates. Spreadsheets are the most used programming language in the world, and ViKiD works mostly in the same way, but enhanced in such a way that you can make games with it. So reactive programming seems like a good technique to avoid many problems in programs. And indeed, it is used in modern software like Facebook React, the most popular web framework in the world. Google Angular, another very popular framework, is also using synchronous data flow signals to model reactive behavior. But in the mission-critical embedded sector, where programs are made to control airplanes, rockets, helicopters, nuclear power stations and more, this has been used for decades. Now, imperative programming is not per se a bad thing. Modern languages like Rust show that if you put enough constraints on it, you can actually create very robust and fast software with it. Let's use Scratch again to show what happens if you don't have these constraints. Let's make a really silly program with 2 control blocks that both move the same sprite but to a different position when the program is started. This is like 2 people giving different instructions to the cat at exactly the same moment. This is obviously a programming mistake, but in larger programs, these kind of things happen, and they are not so easy to spot. We can see that the block on the right seems to win. The sprite is moved to the right. However, if we now duplicate the left block, and delete the original, and run the program again. Now that block wins, and the sprite moves to the left. We ended up with two programs that look exactly the same, but have different behavior. Obviously, parallel blocks with shared mutable state creates a lot of problems in software. Let's use ViKiD to see what would happen if we ask the cat to move both left and right at the same moment. Don't worry if you don't understand the details, we have other video lectures for that. So, let's get started. We load the cat sprite as an image and scale it a bit down. Let's give the formula a name, which is good programming practice. The start event in ViKiD is raised every time you restart the program, just like in Scratch. Every time we click the restart button, we see these yellow lights flashing on all the blocks. We call these blocks signals, just like in electronics. They roughly correspond to cells in spreadsheets. The flashing light is called an update indicator. When it flashes, the signal updates. When we start the program, signals are updated with their initial values. Not every signal in ViKiD has an initial value. For example, the mouse or finger position tracker. The tracker doesn't know what the initial position will be until we touch the screen. When we start the program, we see that the output signal of the tracker doesn't flash and it is displayed in a dark color. This means that the output signal doesn't have a value yet. It is pending and it's not ready yet. However, when we tap the screen or move the mouse while holding down the mouse button, we see that the output signal is updated. Every time we move the mouse or drag our finger, the update indicator flashes. Signals can be visualized using a diagram. Here's a diagram of adding two numeric input signals together. For convenience, instead of using the actual clock time, we use integer timestamps to indicate when a signal was updated. In ViKiD, the timestamp 0 is reserved for signals that are pending. We can see that initially the input signals aren't ready yet. At timestamp 2, input A updates with the value 1, but input B is still pending, so we can't add the values yet. At timestamp 3, input B now gets the value 10, so we can update the output with 11, which is the sum of 1 and 10. At timestamp 6, input A now becomes 2, and the output becomes 12. And finally, at timestamp 9, both input A and B update to 3 and 20 respectively, and the output updates to 23. Microsoft's ReactiveX website uses these diagrams, also called marble diagrams, to document many of their operators. For example, this is a marble diagram of the take-two operator, which is also available in ViKiD, and it just takes the first two updates of a signal and drops everything else. Let's get back to our problem and try to move the cat in an ambiguous way. To move the cat, we select it and apply the function to move it horizontally. And let's say we're going to move it either to -5 or +5. In our demo, we want to move the cat either to the left or to the right. So let's create two more formulas, and we call them x left for the left position and right, x right for the right position. I can now either link the translation of the cat to this binding. We call this a binding, a formula that has a name. We call it a binding, not a variable, because ViKiD doesn't have writable variables. We'll see more in detail about that later. So we can either link to the left or the right. Let us try to reproduce the ambiguous behavior we had in Scratch and other imperative languages by trying to move to the left and right at the same time. So to do that, we make a new binding, let's call it X, and it's going to pick the most recent signal, either the left one or the right one. To do that, we use the merge signal function. And the merge signal function takes the most recent signal. Now, of course, in our case, these left and right signals, they start at the same time, exactly the same time. And in Scratch, that was an ambiguity. But over here, we can see that the merge function will pick the right signal if there's an ambiguity. If both of them flash update at exactly the same time, it will pick the right one. You can see that because the circle in the icon is a bit bigger on the right side. So there is no ambiguity. The cat, if we now link it to the X binding, the cat will always move to the right. The program makes clear what our intent is, and the programmer has to resolve the conflicts. There are other ways to resolve conflicts when two events happen at exactly the same time. There's the merge left, which picks the left signal in case of conflicts, and we can see that the cat indeed now moves to the left. And there's another one where you have to provide a third value when there's a conflict. In this case, for example, I picked 0. So ViKiD just embraces the fact that there are ambiguities and the programmer has to resolve them. This is, of course, not something from ViKiD. It comes from very old languages like synchronous data flow or modern approaches like functional reactive programming. But there is no ambiguity, and that's the whole point of these paradigms, these reactive paradigms, to avoid ambiguous behavior in programs and to allow you to reason about what is going on. To summarize, reactive programming eliminates two major sources of bugs in software. Firstly, just like in spreadsheets, variables are kept synchronized automatically. And secondly, undefined behavior is eliminated because the programmer can't directly write to variables, and simultaneous event conflicts must be resolved. But not all reactive systems are equal. Some systems are only useful for asynchronous programming, and this can introduce glitches. A glitch is a technical term for an invalid intermediate value. The most popular reactive library, ReactiveX or RxJS, developed by Microsoft, Netflix and other corporations, exhibits these glitches. Let's use the RxJS library to demonstrate this. We will make a web page that prints the mouse position to the screen. Again, don't worry if you don't understand the details. We just want to give a more practical example of what a glitch is. So here's the JavaScript code that prints the mouse X position. It takes the mouse move event from the HTML document, and for each mouse move event occurrence, it takes the X position and puts that in a signal variable. Then we subscribe to each event occurrence of the signal and print the value in the HTML body. So indeed, if we move our mouse on the HTML page, we see the mouse X position being printed. Let's now do something different and subtract the mouse position from itself. We do that by combining these two signals, the mouse position and itself, and subtracting the two event occurrences. Obviously, the mouse position minus the mouse position should always give 0, and indeed 0 is always printed in the web view. But if we print the event occurrences, we will see that there's actually intermediate values being printed, and these are called glitches. We can easily fix this by putting a debounce 0 after the combine latest, and then 0 will always be printed. ViKiD is a synchronous data flow language, and it doesn't suffer from glitches. Let's demonstrate this. Let's take the mouse position, change it into hover mode so we can immediately see the result. Take the X position of the mouse, and let's call this X. Then we're gonna subtract x minus x. That gives us 0. That should be the difference. Let's now see that we indeed only get one value and we don't get glitches. So here we use the debug print, which prints to the JavaScript console. And let's see what happens. We always get 0. There are no glitches. So we also said that in synchronous data flow languages and ViKiD, you cannot directly write to variables. Well, you don't have writable variables. So how would you then accomplish something simple as an incrementing counter? For example, how would we make a counter that is incremented when we click the mouse? Well, let's show how. We make the mouse down tracker, and we only want to have a signal when the mouse is pressed. We can do that by using the rising edge detector, and this will only emit an event when the mouse is clicked, when it goes from off to on. Let's call this click. This is the click event. We use the exclamation mark for events. That's a convention. Let's then make a counter that starts at 0. And how do we now increment it? Well, it's a bit like mathematics. We say that the counter starts at 0 and it's followed by the counter plus 1. And here we see that the counter is now incrementing as fast as possible. We also see that there's a red light over here. This means that it's actually the previous value of the counter that is being accessed. We want to increment this counter, but only when the click happens. So we say that the counter is 0, followed by the counter plus 1, when a click happens. This little icon, it takes a snapshot of the input whenever the flash indicator, the update indicator flashes over here. It's called when. So this is how it works. And this is the declarative way of saying what a counter is. There's no external code that is going to write to this counter. The whole story of what this counter can be on this line. Obviously, we can split this in multiple lines and call this the next counter, for example. We can also show this in text mode. So we see that a click is basically a mouse button, the rising edge of the mouse button. The next counter is the previous counter plus 1 when the click event happens, and the counter is 0 merged with the next counter. In the case that there's a constant, we can also read it as followed by. And that's how all, well, variable mutations happen in this kind of systems. Since you can't write to a variable, you always have to say what the next value for a variable is going to be and when that needs to be written. In other videos, we will demonstrate how to build little reactive programs and games with ViKiD. Thanks for watching and have fun!